We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Now see, in this particular lecture, we have concentrate on the example related to system. So first of all, concentrate the first system, which is linear system versus non-linear system. Now, linear system versus non-linear system. So, in linear system, what is the first statement in linear system? It follows the Ohm's law. Linear system, it follows Ohm's law. Now, how to identify whether system is linear or not? How to identify whether system is linear or not? So apply the step number 1. What is the input of the system, which is known as x of t? What is output of the system? It is known as y of t. So I have write here, if system input equal to x of t, system input x of t, now apply input 1 to the system x1 of t, so get output y1 of t, so get output y1 of t, so it is considered as a step 1. Now what is step 2? If system input equal to x2 of t, means apply input 2 to the system, so get output y2 of t. Now for step 3, y3 of t equal to y1 of t plus y2 of t. Step 4, represent y of t in terms of y1 of t plus y2 of t, so get y4 of t. Step 5, y3 of t equal to y4 of t, so system is linear. So system is linear and y3 of t is not equal to y4 of t. So system is non-linear. So it is the steps related to linear and non-linear system. It is the step related to linear and non-linear system. Now, we have solved the example based on that particular step. Remember that point. Any linear system, any linear system must be satisfied the principle of superposition and homogeneity. So this is the condition for principle. See, entire 5 steps that can be clearly indicated by superposition principle and homogeneity principle. So it is considered as a linear system. Otherwise, system is non-linear. Now, I have solved the basic example and the advanced example based on the PDF. So we have concentrate on that particular point. Now, first example, first example, y of t equal to, first example, y of t equal to x of t plus 5. Determine whether system is linear or not. This type of example can be asked. See, this is the example question. This is the example question. Now, step 1, applied input 1 to the system. Applied one input 1 to the system. So y1 of t equal to x1 of t plus 5. So it is the first equation. Step 2, y2 of t equal to x2 of t plus 5. This is the second input that can be applied to the system. Now, what is the third input? Third input means what? Step 3, y3 of t equal to y1 of t plus y2 of t. So is equal to x1 of t plus x2 of t plus 10. See this. This is y3 of t. Now y4 of t, step 4, y4 of t. Only step, this step is very, very difficult compared to previous other step. What is the meaning of y4 of t? Y4 of t means what? It can be represent, or we can say x of t. Whatever input that can be applied to the system, that can be represent in terms of x1 plus x2. That can be represent in terms of x1 plus x2. So I have right here. So you have to able to understand, represent x of t in terms of x1 of t plus x2 of t. Represent x of t in terms of x1 of t plus x2 of t. So y4 of t equal to x of t. Replace x of t with x1 of t plus x2 of t plus x2 of t plus 5. See this very carefully. So y3 of t. Now compare equation 3 and 4. Now compare this equation 3. It is considered as a equation 3. And here consider as a equation 4. Equation 4. So compare Compare equation 3 and equation 4 with each other. Compare equation 3 and equation 4 with each other. So we can get y3 of t equal to y4 of t. Sorry, y3 of t is not equal to y4 of t. See this equation 3 and 4. Here 10 is present, here only 5 is present. So y3 of t not equal to y4 of t. So system is non-linear system. System is non-linear system. So it is the answer related to linear and non-linear system. Based on that, we have to solve the example. So see, this is the first example that I have tried to solve in the whiteboard. So it is the fundamental concept related to system, either linear or non-linear. Now concentrate on the next example. Y of t equal to log bracket ma in bracket of x of t. Log in bracket of x of t. So step 1, apply input 1 to the system. Apply input 1 to the system. Okay, y1 of t equal to log bracket ma x1 of t. Step 2, apply input 2 to the system. So get x2 of t. So get y2 of t equal to log x2 of t. Now step 3, y3 of t equal to y1 of t plus y2. Actually, y1 can be write in the suffix way. I will explain the word, but here in whiteboard it is option is not available. That's why I have write y2 like that. So here we can say y3 of t equal to log x1 of t plus log x2 of t. This is y3 of t. Now what is the meaning of y4 of 3? Y4 of t means what? Represent x of t. Represent x of t in terms of x1 of t plus x2 of t. Addition of two input. Only represent x of t in terms of addition of two input. Nothing else. Don't do any change. So y4 of t equal to log in the bracket of x1 of t plus x2 of t. See, this is. See, consider this is the step 3. Consider this is the step 3. Consider here, it can be considered as a step 4. Now compare step 3 and step 4 with each other. So get y3 of t is not equal to series. This is the logarithmic operation which is not equal to y4 of t. So system is non-linear. So it is the second example based on the system, whether it is linear or not. We can mention each and every step. First example also non-linear. Second example also non-linear. Now we have concentrated on the third example. See this is the entire explanation. Logarithmic operation, it is not equal. Here in individual addition, here addition in terms of x1 plus x2, so it is converted into multiplication. So it is not equal to each other. That's why system is non-linear. Log x1 plus x2 bracket it is indicated log x1 of t into log x2 of t. That's why system is non-linear. So it is the explanation related to non-linear system. Explanation related to non-linear system. Now, third example. Third example, y of t equal to x of t minus 1 plus x of minus t. Determine whether it is linear or not. This is the example data. This is the data of examples. Now, step 1. Step 1 means what? Apply input 1 to the system. Apply input 1 to the system. Apply input 1 to the system. Y1 of t equal to x1 of t minus 1 plus x1 of minus t. Step 2. Apply input 2 to the system. Y2 of t equal to x2 of t minus 1 plus x2 of minus t. So this is the second input that can be applied to the system. Now step 3. Step 3. Y3 of t equal to y1 of t plus y2 of t. Y3 of t equal to y1 of t plus y2 of t. So here y3 of t equal to x1 of t minus 1 plus x1 of minus t plus x2 of t minus 1 plus x2 of minus t. Now step 4. Step 4. Y4 of t. Step 4. Y4 of t. Y4 of t means what? Represent x of t in terms of x1 of t plus x2 of t. So here we can apply x1 of t minus 1 plus x2 of t minus 1 plus x1 of minus t plus x2 of minus t. Now see this equation 3. Consider this is the equation 3. Consider this is the equation 4. So based on that, equation 3, which is always equal to equation 4, equation 3 equal to equation 4. So system is linear. So it is the example of linear system. So try to understand this example. Now we have concentrate on the another example. Now see. Now see. Linear system, non-linear system example. Applied input 1 to the system x1 of t, so output get y1 of t. Apply input x2 of t, so get y2 of t output. y3 of t equal to y1 of t plus y2 of t, and represent x of t. See this here. See here. See here. X of t that can be represented in terms of x1 of t plus x2 of t. So here system is linear, otherwise system is non-linear. Now, now see this, y of t equal to x square of t, determine whether it is linear or not. Now see applied input x1 of t to the system. So y1 of t equal to x1 square of t. Similarly y2 of t, applied input 2 to the system. So x2 square of t. You can write x2 like that. Also we have discussed in the whiteboard. If you can write multiply with x2, then it is also no problem, but it is standard thing. Now see, this is input y, output y of t. Whenever x2 of t, that can be applied as an input. So y3 of t equal to x1 of x1 square of t plus x2 square of t, and represent x of t. Now see this. Now see this. Represent x of t. Represent x of t. Represent this x of t in terms of x1 of t plus x2 of t. Represent x of t in terms of x1 of t plus x2 of t. It is. So here x1 of t plus x2 of t all square. So y3 of t not equal to y4 of t. So it is non-linear system. See this here. It is considered as a non-linear system. Now, now, now see this. Y of t equal to sine x of t. Next example. So applied input 1 to the system, sine x1 of t. Applied input 2 as a system, sine x2 of t. Now applied addition, sin x1 of t plus sin x2 of t, individual addition. Now represent x of t in terms of x1 of t plus x2 of t, means here we can apply x of t is equal to x1 of t plus x2 of t. See, this is the considered as a step number 4. So if you can represent that, so sin x1 of t plus x2 of t, which is not equal to, see this very carefully, which is not equal to sin x1 of t plus sin x2 of t. That's why it is known as non-linear system. That's why it is known as non-linear system. So we have to solve the number of examples based on this lecture. Depends on particular this lecture. We have solved the more number of examples based on the system. Now see, y of t equal to t into x of t, t into x1 of t, t into x2 of t, y1 of t plus y2 of t. So t into x1 of t plus x2 of t is equal to y4 of t. Individual addition plus x of t represent in terms of x1 of t plus x2 of t. Obviously, it is linear system. Follow the principle of superposition. Now see, here if we can change, see here entire square that can be present. Here a plus b, a square plus b square type of term present. Here a plus b all square is present, so it is non-linear system. See this is non-linear system. But why? Because here we can apply the a plus b all square. Then it is known as a square plus 2ab plus b square. This type of formula can be developed here. So it is non-linear system. But I have just changed the silly change in this particular example. આ example માં થોડોક જ data change કરું. X square of t ની બદલે xt square કરી નાખું. So see, this is the next example. Xt square. What is the meaning of xt square that I have discussed? What is the meaning of xt square, and determine whether it is linear or not? I will explain in the Microsoft Word. See this, insert the equation. Insert the equation. Here we can write x t square is equal to y of t. Now determine whether it is linear or not. Determine whether system is linear or not. So first step y1 of t y1 of t is equal to x1 of t square x2 of t square y2 of t equal to, now y3 of t equal to, see here, y3 of t equal to x1 of t square plus x2 of t square. See, this is y3 of t. Now y4 of t means what? Represent x of t in terms of x1 of t plus x2 of t. So here y4 of t, here we can remove this term, y4 of t equal to x1 of t plus see this. Now see, this is the equation 1. It is known as equation 2. So equation 1, which is equal to equation 2. This two equation is equal with each other. That's why system is linear. That's why system is linear. Y of t equal to x square of t, and y of t equal to x of t square. See this, I already solved this example related to that. X of t all square. See this. It is linear. It is linear system, but it is non-linear system. non-linear system. I have explained this in the PDF of my solution, and here I have explained this particular thing. Here I have explained this particular thing. See this y1 of t, here y2 of t, here y3 of t. It means addition of these two, and y4 of t represent x of t in terms of x1 of t plus x2 of t, and compare equation 1 2. So system is linear. So this is the example that I have discussed here. See this is the most important. With reference to GTU examination, directly this question can be asked, whatever marked with circle. So please try to prepare this very carefully. It is the very important example related to linear system or non-linear system. Now see this next example, e raised to t x of t. Obviously e raised to 0, if you can apply 0 input, so output is 1. So obviously system is non-linear, but still you can apply the input 1. So e raised to t x1 of t, y2 of t, e raised to t x2 of t, y3 of t, y1 of t plus y2 of t. So e raised to t into x1 of t plus t x2 of t, and y4 of t equal to represent x of t. See this here. What is the main step in y4 of t? Majority students have do mistake here. Y4 of t means what? Applied x of t is the input of two input addition, x1 of t plus x2 of t. If we can apply here if we can apply here x5 and x6, then also we have right here x5 plus x6. So here is 2t bracket my x1 of t plus x2 of t. These two systems are non-linear. So it is considered as a non-linear. Why non-linear? Because result is different. So it is considered as a non-linear system. It is considered as a non-linear system. Now see, this is the complete step regarding the non-linear system and linear system based example we have to try solve in this particular class. Now, next system, which is known as static system and dynamic system. What is the meaning of that? I have not solved the example related to that in this particular lecture, but what is the meaning of that system? Static system and dynamic system. A static system means what? Output of the system depends on output of system depends on present input only, or data cannot be stored inside memory. So it is static system. And what is the meaning of dynamic system? What is the meaning of dynamic system? If output of the system, if output of the system, output of the system present on past as well as future input, so it is known as dynamic system. So it is known as dynamic system. Output of system depends on present input, so only, or data cannot be stored inside memory, so it is static system. If output of system present depends on output of system depends on, I have add the word here, output of system depends on present on past as well as future input, so it is known as dynamic system. Real time all systems are considered as a dynamic system. So it is the basic introduction about the static and dynamic system. Now see, I have right here x of t is equal to present input. X of t consider as a present input. X of t consider as a present input. X of t minus 1 indicate delay. That's why indicate past input. X of t plus 1 indicate future input. That's why it is considered as a advanced input. That's why it is considered as a future input. Remember this point. Try to understand these three terms very clearly. Try to understand these three terms very clearly. That's why I have highlighted with different mark past input and future input. Simultaneously, x of minus t also known as future input. Why? Because if you can put t equal to 0, t equal to minus 1, then here output we can get x of plus 1. Here output we can get x of plus 1. That's why it is considered as a future input with respect to time. Consider only the line number. See this, consider only the line number. If here we can get the value, if here time is minus 1, we can get the future value like plus 1, plus 2, plus 3. So it is considered as a future input. So here I have discussed the concept about the fundamental concept about the future input, past input and present input, and also discuss about the static and dynamic system. So based on that, we have discussed example of next lecture. In today's lecture, we have discussed the example of linear, non-linear system and steps to be followed by linear and non-linear system, and also understand the types of system with example. So thank you very much.